Have you ever thought about how points on a line can correspond to numbers on a ruler? Of course you haven't. You're a normal person. But it does, and that's called the ruler postulate. A postulate is something we accept to be true without any other proof. It is so basic and practical that it doesn't need further explanation. So the ruler postulate states that points on a line, like here, A and B, can correspond to real numbers on a ruler, like here. I could match these up to 12 inches and to 2 inches. Those real numbers are called coordinates. This idea of points on a line corresponding to numbers on a ruler helps us talk about the idea of distance, which is our focus for today, specifically the distance on line segments. The distance between 2 points A and B can be written as AB. And notice there's no symbol above that. And this is the absolute value of the difference of the coordinates of A and B. So if you look in this figure here, okay, we have this line AB. The distance between them, AB right here, okay, is represented by the coordinates that we assign them. So A is at x sub 1, B is at x sub 2, and their distance is the absolute value of the difference between them. So I would take x sub 2 minus x sub 1, whatever value B is at, minus whatever value A is at, I'd take the absolute value, and that would be the distance between them. Okay? So notice again how we write this. This would be segment AB, and this would be the length of AB. Okay? Notice how those two things are different. Why absolute value? Remember, a number's absolute value is its distance from 0, which will always be a positive number. So when we're talking about distances on a line segment, we want to use positive numbers. Line segments that have the same length are called congruent segments. You'll hear that word congruent a lot, but pay attention to its important distinction. We say lengths are equal, and we use the notation, the equal sign. So we would say that in this picture here off to the left, that the segment AB, the length of the segment AB is equal to the length of segment CD. But we say segments are congruent. And so we would use this notation. I would say segment AB is congruent to segment CD. That symbol there is the congruent symbol. It's an equal sign with, looks like kind of a little squiggly above it. Okay, that's the congruent symbol. Why aren't those the same thing? It's because lengths are values. Like look at this segment here, segment AB. It has the length of 10.5 inches. That's a value. And this segment CD has the length of 10.5 inches. That's a value. The lengths are the same, so we say they're equal. They have equal value. But they are two different segments. They may have the same length, but they're not the same segment. So we call them congruent segments. If we were to call them equal, we would be saying they're the same thing, but they're not. So figures are congruent, but lengths and values are equal. Last for today is the segment addition postulate. Let's look at the figure here. It'll model the postulate for us. If B is in between A and C, B right here is in between A and C on the line, then the length of AB, the distance from A to B, plus the length of BC, the distance from B to C, is equal to the total length from A to C. Notice that the reverse is also true. If AB plus BC is equal to the total distance from A to C, then that means B is in between A and C. Okay? So we learn about the point from their distances, and we can learn about the distances from where the points are. These are some of the geometric concepts about distance and segments and lengths. We'll explore more later. For now, jump over to lesson 1.2 examples to see how this all works.